All right, so I did my paper in association with Dr. Prouse in Astronomy 112. I'm sorry, Astronomy 101, my bad. The topic is, as he said, solar activity and early history, although it's kind of a misnomer. I do go a little bit into medieval and early modern history, but the reason I chose this is just I do a lot of history reading, and I see a lot of people put a lot of stock into the idea that technology or great rulers or resources or geography play the main role in historical development. And through this astronomy class, I could see that there are certain effects that were done by celestial bodies that might be the cause for some of these other factors, and I thought I would poke my head into the subject. So before I can really get into that, though, I'll have to cover a couple other topics. I'm going to do a quick overview of the solar cycles, like what they do, why they happen, what a grand cycle is, how that affects the climate, food, and population, and even like general kind of trends of thought within a populace. And then once that's through, I'll be able to go into the actual meat of the topic and talk about the historical side of the subject. We're going to start with the Homeric minimum, go into the Roman warm period, and then discuss the Little Ice Age and its fallout, and hopefully we'll have a bunch of time for questions. So to start, we'll talk about what causes a solar cycle, and what it is essentially there are magnetic field lines that run down north to south on the surface of the sun. And as it twists in its rotation, these lines tend to kind of furl into each other and push away from each other. And as it continues to turn and they continue to twist, this gets more violent, and the surface of the sun itself becomes more and more unstable, creating sunspots or solar flares or coronal mass ejections. And so the starting point where it's blank and its lines are straight is what's called a solar minimum. And its zenith, which it hits at about every 11 years, is what's known as a solar maximum. So at the point that it hits its solar maximum, its polarities switch, and the cycle is repeated for another 11 years, creating what is known as the 22-year pattern of a full solar cycle. These cycles are usually incredibly predictable, and will usually remain relatively the same amount of time in length. However, when these periods are extended, we see a rather large change on Earth within civilizations. These extended cycles, which are referred to as grand cycles, are composed of many smaller solar cycles, creating a sort of overarching trend towards a grand maximum or grand minimum. And these grand cycles are what really force these climactic changes on the planet. So I would like to say, before I get into this, that solar activity is not the only reason for these changes, though it is a rather large factor. Things like seasonal winds or ocean currents or volcanoes can also cause similar shifts, though the periods that we'll be talking about will be almost predominantly caused by these solar cycles. However, there is heavy correlation to suggest that most of these changes are done by these grand cycles. We see a lot of change in climate in that during minimums we have a drier climate with erratic rainfall. It's a lot windier, and because of this sort of erratic environment, plants are less able to thrive, and as such we see a lot of negative crop yields and crop failures. And there's a rather high impact on just normal survivability, in that you can't sleep outside and expect to live often during these things. And a solar maximum is a little bit of the opposite. There you have a lot more consistent temperatures. You have a lot almost tropical environment. You have positive yields and usually surplus food, and less impact on this regular sort of habitability. And this also comes into play with temperature, in that during a solar minimum, you have a lot lower temperatures on the mean, and during a maximum, you have a lot higher. And you can see it here. We'll talk about each of these points at some point. But So, as I said earlier, these solar minimums cause outright crop failure, which leads to a lot of societal pressure. In that, with less food, a lot of the populace tends to blame leadership and tends to rail against them. You see a lot of sort of a want for territorial and governmental retention within governments, and you see an absolute lack in expansion during these periods. Whereas during a solar maximum, you see a great number of expansion. There's a surplus in food, so there's a surplus in population, and therefore a much more sizable population of expendable people for an army. And as such, during these periods, we see a lot more war, a lot more organized fighting, and a lot more territorial grabs. So, to start, we're going to go into one of the earlier climactic events called the Iron Age Cold Epoch. And during this period, there's a 90-year era that comes to be known as the Homeric minimum. And as such, we will be focusing on Greece for this part. It coincides with the solar minimum and a lack of irradiance to suggest that this solar cycle is the cause of these changes. There's a focus on trade and technology advancement, which we'll get into, but the most interesting thing about this period is that there is an almost complete lack of warfare within this 90-year span. The only one of note that I could find was an Assyrian campaign against territory that had been traditionally Assyrian, kind of keeping towards this societal and global trend of territorial retention instead of attempts at gaining. And because there's a lack of war due to this lack of usable population, we see an explosion of trade and the foundation of Carthage. During this 90-year period, it really is allowed to boom because there's no one to fight them, there's no one to raid them, there's no one to do anything against them. And because of this, we see an empire form based on trade and not warfare. However, some 50 years after this, we see a 300-year period of what's known as the Roman warm period. We see a rise of global temperatures, a rise in mean irradiance, and much higher levels of solar activity, leading to higher temperatures, which allows for greater crop growth and a much larger boom in population, if you see that first little bump there. The period has come to be known as the Roman warm period because it was the time in which the empire actually completely rose and fell in power during that 400 years. And during this time, because there's such a sizable population, we see expansion through warfare. We see a much more stable climate. We see much more crop yield and just essentially an easier way of life for these people. We see the advent of farmer soldiers that are allowed to do so because they live in the environment they live in. And it allows for the rapid expansion and influence of Rome. And this is a global pattern. We see it in China as well, and also in Persia. With China, we see it during the Qin unification, where he takes essentially very small population, it explodes in size, and he's able to use that to unify all of China. But with the end of the Roman warm period comes to the end of the Romans, when 10 years later Rome falls, and it is not until several grand cycles that we will see another empire like it. Sometimes after, we have the Vandal minimum, which is caused predominantly by volcanic activity, so we're not going to talk about that. We have another warm period known as the medieval warm period. That is possibly due to solar activity, though it's really just the same kind of thing. You see a lot more formal warfare. You see a lot more organized acquisition of territory through conquest. And then after that, we see what's known as the Little Ice Age. The Little Ice Age is a little contentious with dates. A lot of people really disagree where it starts. I tend to use 1300 just because it's where we really start to see this loss in solar activity, and where it really becomes noticeable. It's actually composed of several grand minimums, known as the Wolf, Sporer, and Maunder, and also the Dalton, but we won't touch on that. And it starts what is essentially the most unstable point in human history. To kick it off, we have the Great Famine of 1315 to characterize the continuous crop failure throughout the age. About 8 million die by a rough estimate, and this mean of starvation throughout Europe also leads to much weaker immune systems on average, and it allows a war path for the Black Plague, which will wipe out a third of Europe. This population decline causes panics within the general public and the poor, and we see a large surge in revolution during this era and an inability to retain governments at this time. So to go a little bit more into it, during the Wolf and Sporer minimum, food shortages and crop failure, like the famine of 1315, lead to the Black Death, and this amount of death leads to an abject loss of faith in Christianity within Europe. We see a move towards self-spiritualism in Lutheranism, and the consequential civil wars and wars of religion that arise out of that. Following the Wolf and Sporer minimums, we have the Maunder minimum, which is quite possibly the worst conditions that we've seen caused by solar activity. Crop failures abound. Due to this, we see the highest number and most concentrated number of peasant rebellions, possibly until the modern era, pre-slavery, post-slavery era. This period accounts for about 21 peasant revolts in Europe, I think about 3 in Asia and 5 in Africa over the course of 65 years. It's followed by the Dalton minimum, which is volcanic in origin, so we won't really touch on it. But so to conclude, during warm periods, during grand maximums, we see a surge in expansion through territory, through conquest. We see, because there are more people that are alive and usable as soldiers, we see a lot more empires appear during ages where there is a grand maximum present. Whereas during grand minimums, because this is so small and because there's so much panic going on at the time, we see a retention and, failing that, a collapse of governments. So it is worthwhile to study this, so that, if we see an event like this happening, like right now we live in a modern maximum, and it gets to be too hot and we start to see these crop failures, then we might be better able to prepare ourselves in the event of something as disastrous as the Maunder minimum. That's it. Thank you. Any questions? That affected what? I would say either the Roman warm period or the Maunder minimum. The Wolf and Sporer minimums, just because of the loss of life was so incredible that it actually caused carbon emissions to go down. The Roman warm period allowed for the expansion of Rome, which allowed for what is essentially the proto-West as we know it. Yeah, if it wasn't for the Roman warm period, Rome would not have been allowed to exist. There's no way that empire could have had the success that it had at any other point in time.
Is
Anything else? Well, it happened several times, but I think that the reason that that instance was so impactful is because of that starvation, because of the lack of nutrients in people at that time. It was a feeding ground for sickness. I actually don't think that we should be worried about a minimum. I think because you're right, we do have a technology to kind of curb the problem with that. I think the worry that we should have is a grand maximum that goes above what we've seen, because we're a lot less suited to handle heat with plant life like that. So that question is actually the reason that I did early history. I think it's very possible. From what I've read, that's what's happening. Right now we're in a maximum, and it seems to be continually increasing. Yeah, and I... Possibly. I mean, very possibly. It's hard to tell because it's not in hindsight. So I mean, we can't really measure anything like that yet. But I think it's possible. I think it could be if we really truly are in a maximum right now. I think that it will hit us much harder. Anything else? All right. Thank you.